Video I have started with straight lines, and also I have done how we can find whether two lines are perpendicular or two lines are parallel, and how we'll find the slope of a line if angle is given and if the coordinates are given. So in that manner I have summarized most important points, and also I have derived few results. Similarly, in this video we are going to see that why slope of the line was our prime interest, because if you know the slope of the line, we can see that how many things we can find out about that line. For example, if there are two lines, consider that two lines intersecting each other. We already saw that when two lines are parallel, their slopes should be equal. So I am not considering that case, but considering that if two lines are intersecting each other, for example, let the lines be like this. So these two lines are intersecting each other, and this angle is theta 1, and let this angle be theta 2, and also we want to find the angle of intersection, the angle between two lines, right? We can find, now you can say there are so many angles, right? How we will find angle between any two lines? How we will determine? First thing is this angle. The first thing is this angle. So this is a this is a I can say that this angle is acute angle, right? Because this angle is less than 90 degree. And also one more angle is there. For example, let me name it as this one has theta. And also there is one more angle. This one is a, I can say that this is 180 minus theta. Let me write it as 180 minus theta, because since it is a linear pair, I can write it. So these two are angle between two lines. Now, given that we know these theta 1 and theta 2, how we are going to compute the angle, either theta or 180 minus theta, anything, both are same. Because if you know any one, you can compute the value of theta. But we are generally interested in acute angles which are less than 90 degree. We don't want an obtuse angle. So we are going to see that our from the slopes of the line, how we are going to derive that result, because that is very important. This label as obviously x and y. So consider that this again theta 1 corresponds to line 1 and theta 2 corresponds to line 2. I am not naming this all. So we know the slope of line 1, that is line 1 slope m1 is equal to tan theta 1, and also m2 is equal to tan theta 2. From the definition of slope, this is very clear. So now also, now I am going to consider that, and once again, there is a catch here, right? Now one more condition will come. Suppose I am talking about two lines which are vertical to each other. For example, let me consider. I am not going to have this one, right? If the two lines are vertical to each other, then there will be again a point of undefinite. There will be a point where you cannot define the slope, because if you see that if they are that is because one angle will be 90. Suppose this angle is parallel to this angle is parallel to y-axis, so this theta is 90 degree. So in this way that two lines should not be vertical. So I am going to derive angle between two lines, and I am considering that already I am presuming that theta should not be equal to 90 degree. So they should not be equal to 90 degree, because if they are equal, then we know that the slopes are m1 into m2 is minus 1. So how we'll find the perpendicular lines? But we can't we don't want to compute the angle between them, because that will bring an infinity term. So we will consider that theta is not equal to 90 degrees. So non-vertical lines, this condition is non-vertical lines. So now I am going to start with this. How I am going to now we'll find the relation between theta 1 and theta 2. So similarly, you can very clearly observe now that this is a exterior angle. For example, this is also theta. Vertically opposite angles are equal, right? These two are intersecting, so this is theta. So now I can write that from this triangle exterior angle property, theta plus theta 2 is equal to theta 1. Aren't you agreeing? Because if you check these two angles, interior angles should be equal to exterior angle, right? So now I can get theta in terms of, which implies theta is theta 1 minus theta 2. So this is nothing but a relation between theta 1, theta 2 and theta. This will be very useful. Now also we are assuming that I have already mentioned that theta 1 comma theta 2 should not be equal to 90 degree. This will be valid. So therefore now I want to find the slope of the line. For example, if I want to find the slope of the line, slope that is tan theta is nothing but the slope at this point. Slope is equal to tan theta, which is equal to tan theta 1 minus tan theta 2. So why we are doing tan theta? Because we already know the value of tan theta 1 and tan theta 2 because they are slopes. And also we can find the theta also in that way, because tan theta, if we know the theta, right? Because if we know, if suppose tan theta value is 1, then theta is equal to 45. We can clearly say from the trigonometric tables. So that's why we are interested in computing tan theta. We are directly not computing theta because it doesn't make any sense, because we can compute directly, but for now we are considering that we want to compute in terms of trigonometric ratios. So, and also there is a reason why I have taken tan. So now there is a formula. If you come across it, I will write it down. Tan A minus tan B. So tan A minus tan B is equal to tan A minus B is equal to tan A minus tan B by 1 plus tan A into tan B. So this is the trigonometric identity which we will use here. So now after using this, now you might have got what I am doing here. This is very simple. After this, you only substitute m1 and m2 and you get the answer. Theta 1, tan theta 1 minus tan theta 2 divided by 1 plus tan theta 1 into tan theta 2. So this one we know the value of tan theta. This is the slope of line 1. So similarly I can put it like this. So which is equal to m1 minus m2 by 1 plus m1 into m2 tan theta. So this is the angle which we need. So this is the angle which we need now. And also we assumed from this also it is very clear that 1 plus, or I can say that 1 plus m1 into m2 should not be equal to 0, because this implies that they are non-vertical lines condition. If this is equal to 0, then we know that m1 into m2 is minus 1, which are perpendicular lines. Again, as I stated earlier, this condition, this is very implicit. If you are very aware that why this condition comes, it should not be 0. It is mathematically, and also I have said also qualitatively I have mentioned it. Similarly, now I have said that this theta 180 minus theta is also angle between two lines. So let me compute that also. 180 minus. So I know that tan, if you know some about trigonometry, tan is tan theta is negative in the second quadrant. So this is 0 degree, this is pi 180 degree. So 180 minus theta will come to again second quadrant. So that is nothing but minus tan theta, which is also equivalent to, now we know the value of tan theta. Tan theta is m1 minus m2 by 1 plus m1 into m2. So I can write minus tan theta as m2 minus m1 by 1 plus m1 into m2. So we know these two formulas, these two can be used identically. So we want such a way that we don't want that minus sign to come in the numerator. In denominator, we know we don't want that. We want only want to find the angle. We don't want the negative sign, because as I earlier said that we want theta between 0 and 90 degree. If theta is between 0 and 90 degree, we know that positive. It is a positive. Tan theta is positive here. Similarly, in that manner, I will only take the positive values. How I am going to take the positive values? So we will consider a mod operation. I will take a whole modulus and write it as, and I can write it as, you can write it as m1 minus m2 or m2 minus m1, anything is fine. M2 minus m1 by 1 plus m2. For example, many students get a confusion here. This is the answer. This is the required expression angle. So this is a required expression. Uh, so now I can say one thing here. I want to say two conclusions. One is that, for example, I will take, if m1 is greater than, if m1 equal to 2 and m2 is equal to 3, for example. So I'm going to get something like this. Hmm. Let me take, yes, let me take m2 is equal to minus 3. So it will be more clear now in this example. So if I take m2 is equal to minus 3, so the tan theta is minus 3 m2 minus m1 by 1 plus m1 into m2 minus 3 into 2. So what we get? It will be minus 3 minus 2 minus 5. Also it will be minus, plus into minus is minus. So 1 minus 6 is 1 minus 6 you get. So we know that now I don't want this minus sign to come here. We know that this is minus 5 by minus 5. So this is minus 5 by minus 5 and this is 1. Now I am not taking that much. Minus 5 minus 5 1, but you got a positive value already. But for example, here in the denominator, if there is a positive value and numerator negative value, we want only the, we know that if tan theta is 1, then theta is 45. This is very clear from a trigonometric table or trigonometric ratios. But if we get some other value like minus 5 by 6, then we don't want that negative sign to come, because we want, again I am saying that we want acute angles, we want angles less than 90 degree for convenience. Still we can compute this 180 minus 90 degree, but still that is simple, because if we know one angle, for example if I say that 30 degree is angle between them, so is 150 degree, this will be negative because that is in second quadrant. Similarly, this is positive because that is in first quadrant. If you know trigonometry, a little bit of trigonometry, you will understand what I am talking about. So I am not going to stress more here, and this is an important result here. Tan theta is, we'll only take the positive value. Don't get scared by seeing this mod operator. This nothing but you will only take the positive values, both the numerator and denominator. This implies only that thing. If you don't get a negative value, well and good. So you don't need this mod operator. But in case you get negative value, then you have to discard that minus sign. For that, we are using this modulus operator. There is nothing more difficult in this. Similarly, there is one more concept. With the slope of the lines, we can do one more thing. We can compute one more result. We can compute one more result. That is, we can find the collinearity of lines. Collinearity of points. Collinearity of points. So now, what is collinearity? This term little bit is looking complex, but let me make it simple now. Because consider an example, I will draw again. I am considering only Cartesian coordinate system, x axis, y axis, and I draw a line. I am drawing a line, straight line, only straight line. Yeah, discussion. Sorry for this straight line, and also now there are 2 points inside it. So, for example, let me consider that there are 3 points. These 3 points lie in the same line. So then I can say that if these 3 points lie on the same line, they are collinear points. They are collinear points, I can say. So why? You know that definition of collinearity. Why? This is simple because if you know there are so many points, if they lie on the same point, we know that they make a same line. But if I take 2 points here and one more point here, this two make one straight line, but here this two make another straight line. So this implies that any given 3 points are collinear if they are present in a same straight line. That is, they are part of a same straight line. They are part of only one line, not two or three lines. So we know that a line, any given line can pass through two given points. We can define a line. We already mentioned it, x1, y1 and x2, y2. So from this, from two given, we will see later that if we know two coordinates, then we can define the equation of straight line. So in this manner, if to define the collinearity, we have to have the third points. It is defined only for two or more points, more than 2 points. For example, if 3 point come in 3 points come in same straight line, then they are all one. There is no need to consider one point. So there is one redundant point, I can say. So that's why we consider this concept of collinearity. So that is very useful. So we will see how it is related to the slope, and also how we can find that the points are collinear given the slope. This is quite simple. I will name these points as A, B and C. So we can very clearly say that for example, if I take the slope of these 2 points, if this I consider as a one line segment and this I consider as one more line, then if the slopes of both the lines are equal, for example, if the slopes of both the lines are equal, then I can say that if the slopes of both the lines are equal, then I can say that then they are collinear because they make a same line. So that means I can say that a condition is slope of AB is equal to slope of BC. Slope of AB is equal to slope of BC. So collinearity of points, I can consider that there are two strips of line. So I can say that if slope of AB is equal to slope of BC, similarly if there are 4 points, for example, you find whether they are collinear or not, then I can say that another condition you have to add. So slope of BC is equal to slope of CD. So in similar way, for so many points you can do. This is the condition of collinearity. So this is very obvious result. So now I am going to end here because this is all about collinearity. We have seen so many things from the first we started the slope of a line, and also sometimes one more thing I have to mention that theta is their angle. So if I consider this, for example, any straight any line, angle with x-axis, positive x-axis is theta. So this theta sometimes is called as inclination of line. So this angle is also called as inclination. Sometimes there are so many same words. Slope also similarly I have said that slope is defined. Slope is also with respect to inclination or with respect to angle tan theta. But if we know equation of the line, then I can define it by using dy by dx. If you know differentiation, using differentiation. And also in terms of point, if we know 2 points, then how we can find the slope? So y2 minus y1 by x2 minus x1. Similarly, the condition for parallel lines, two parallel lines. Lines can be said parallel lines only if slopes are equal. Their slopes are equal. Similarly, perpendicular lines, their slopes, the multiplication of their slopes is minus 1. So two lines are parallel means implies that this is the result here. We get the result from we get to know about the slopes. If two lines are perpendicular, then we know that if two lines are general angle. So to find the angle between two lines, then it is more m2 minus m1 by 1 plus m1 into m2 mod. So this all the result we have seen from the beginning, and I am going to solve the problems, few problems in the next video. Thank you.